Okay, everybody, this is this is the review for tomorrow's test. Just like we had done in class today, but I thought it'd be a good idea to put a little video out along with it. Okay, the first question: name the element that contains 11 protons, 11 electrons, 12 neutrons. Well, to find out what that is, all you have to do is look at the number of protons we have here. That's the same as the atomic number. So I guess I'll put that out there. And if you look at that, that's going to be sodium. So make sure you have your periodic table. There's a symbol for sodium also. When you have an atom that has equal numbers of protons and electrons, that atom is neutrally charged, or a neutral atom. There is no charge to it. Okay, no charge. No ions at all. An atom with unequal numbers of protons and electrons, now that's different. We don't know what kind of ion it is, but we know that it is an ion. So the answer is simply ion, an ion. There we go. A cation is a positive ion. An anion is a negative ion. All right. Now the key in this next phrase, when you see different numbers of neutrons, always, always, always that answer is going to be isotopes. Okay. Number 7. Two particles of an atom that are found in the nucleus. We have protons and we've got neutrons. Now the electrons you will find orbiting the nucleus. And typically people will call it the electron cloud. All right. The scientists that believed atoms traveled in a fixed orbit around the nucleus, like planets around the sun, that would be Mr. Bohr. The plum pudding model to describe atoms with randomly placed negative particles, that one belongs to Thomson. And we fixed this. This is calcium 40. When you go and try to find calcium in the periodic table, you're going to see that the atomic number is 20. Therefore, the number of protons is also 20. The number of neutrons is found by taking the mass number and subtracting the atomic number from it. And that would be 40 minus 20, and that's going to give you 20 again. Okay, now let's go to 12. If the atom changed the number of protons that it had, what would happen to that element? Well, it changes its identity. It's no longer the same element. If you add a proton to an element, it becomes something else. If you take one away, it becomes something else. All right, nuclear notation, answering the following questions. How many protons? The protons are found by looking at this number here. That number is the atomic number. So there are 3 protons. Number of electrons, that's different. In a neutral atom, there would be 3 because there are 3 protons. But what we have here is an ion. This right here says that there is 1 less electron. Okay, therefore there are 2 electrons now. It is a cation. How many neutrons? Well, that's 7 minus 3, and that would be 4. This number right up here is the mass number. Okay. The gold foil experiment to suggest protons are located in the nucleus, that would be Rutherford. And a few more questions. Protons, neutrons, electrons. How many protons here? Well, we'd look right there, and there would be 17. That 17 is the atomic number. Number of electrons? Well, we still have an ion now. This says that we have 1 more electron than we had. Okay, so now instead of 17 for a neutral atom, we would have a total of 18 here. The number of neutrons is the mass number minus the atomic number. 36 is the mass number, 17 is the atomic number. 36 minus 17 is 19. And this is a chlorine ion. Right? I'm going to save the math for last. Right here. For a neutral magnesium atom to become an ion with a +2 charge, what must it do? Well, it's quite simple. You can only add or lose electrons. So in this case, in order to become a cation here, it has to lose 2 electrons to do that. Okay? That means they have 2 more protons than electrons, if we say it that way. Now, when you have a potassium ion like here, it has 11 protons and it's 13 electrons. That is an ion. It would only be neutral if you had the same number of protons and electrons. But we don't have that. We have 2 more electrons here. So the charge is being a -2 charge. And then to identify the element below, all you have to do is look at the number of protons. And there are 9 in there. That happens to be fluorine, because all you have to do is find the atomic number 9 in the periodic table, and you get fluorine. Okay, now to the math. 2 isotopes, chlorine-35 and chlorine-37. And put chlorine-37 here. We're going to multiply the mass to find the average atomic mass here with its percent abundance. So 34 point, oops, that's a bad looking 3. Let me make it better looking. 34.9689 times its percent abundance. We're going to make that a decimal. We're going to make that 0.75771. And the answer that we got for that today was 26.50. We take the other mass, which is chlorine-37 mass, 36.9659 times this percent abundance. We're going to change that to a decimal, 0.24229, and we're going to end up with 8.96. Then all we have to do is add those together. We get 35.46 AMUs. Okay, box our answer. Same kind of process with the copper 63 and the copper 65. And so they'll take the mass of the copper 63, which is 62.93 atomic mass units, multiplied by its percent, 69.1, change it to a decimal, make it 0.691, and we get 43.48. Last one. The mass of the copper 65 being 64.93, multiplied by its percent, which was 30.9. We'll make that 0.309. Move that decimal 2 spots to the left. And we're going to get 20.06. We're going to add those 2 numbers together, and we find that a percent abundance here, average atomic mass, 63.54 AMU, and that is that. Please study, please study, please study. Good luck tomorrow on this test.